Problem number 8 brings us back to a theorem at the top of the notes yesterday, talking about what happens when we take the derivative of the antiderivative. And number 9 does the opposite, the antiderivative of the derivative. Talked about how one of these, we have a plus c in our answer. We get what's left on the inside, or what we originally had on the inside, plus c. The other one is just the function on the inside. So let's take a look now that we have a better idea of how to do these integrals. Let's see which one has the plus c and kind of see why. So we're going to do order of operations, what's in the parentheses first. We're going to do the antiderivative of this. So this d over dx is still out in front. And we're going to do the antiderivative of this little function. So we're going to add 1 to the exponent and divide by the new exponent. So divided by 3, we're just going to have x cubed. And then for this one, we're going to add 1 to the exponent and divide by 2, so we get minus 4x squared. So there's our antiderivative. Now we're asked to take the derivative of that. So if we do that, we end up with 3x squared minus 8x. So we can see that, like we talked about yesterday, we end up getting exactly the same thing we started with. Now with number 9, it's slightly different. For this one, we're doing the antiderivative of the derivative. So again, we're going to kind of show the work on this one, but after this, you don't have to show the work anymore. You can just figure it out. So this time, antiderivative staying on the outside. Derivative of the inside, we take the derivative of 6x to the 5th, we get 30x to the 4th minus 28x cubed minus 2 dx. So now, when we go to take the antiderivative of that, you would think we get the same thing we started with, and you do, but with one little extra part. Because if we take the antiderivative of this, we add 1 to the exponent, divide by that new exponent, we get 6x to the 5th, just like we had here. This one, add to the exponent, divide, we get negative 7x to the 4th, like we had. And here we get minus 2x. Difference here is we need to remember the plus c. So we end up with the same thing that we started with, except we also have the plus c. And the reason is because the integral is on the outside. That's the last thing we do. We have to do plus c. And now that I look at it, I forgot about that in number 8. If we look back to this one, sorry, when we do the antiderivative, we should have the plus c. Right? Antiderivative 3x squared minus 8x, we have the plus c on the inside. But the whole point of this was to show you that once we do the derivative of that, derivative of a constant is 0, so that c drops out. Here, since we have the integral, that's the last thing we do, we have to have that plus c still. So it all depends on what we finish with. If we finish with the derivative, c cancels out. Finish with the integral, we need the plus c. So with that in mind, try number 10. It looks hard, but since we're doing antiderivative of the derivative, it really isn't. All right, so for this one, do we have a plus c or not? Since we end with an integral, we should have everything on the inside here is going to stay, and we need a plus c. Right, since this is here, on the outside, we get a plus c. If we had these switched around, we had the derivative on the outside, then the integral, no plus c is needed.